Hi, it's Gadget UK here again. The Nec Rgb Pcb is turned up. As you can see, it's a nice little board there from OSH Park. I'll post some links to this in the description. You can see you've got the component listings on the back there. I think I'm just waiting for a couple of components, and I think the electrolytic caps I've got to go on there are a bit too big, so I might need to order some different ones, yeah, unless I can get them on there. I don't know, I'll have a look later. So I thought it would be a good idea to show you the assembly process here. It's always useful, I guess, to see how techniques and things for mounting small SMD components. It's pretty straightforward, actually. The main thing is you need something like some good quality flux. I always use this Chip Quick stuff. SMD components. You can see got a little, might just be off camera actually, little cap there that needs to go in the first position. C1, I think that's 82 nanofarads. So we'll get a little bit of flux onto the PCB first. Get the component on there, you can pick it up. Try and get it in the right position. That's it. I'm going to try and do this without obscuring the shot here now. Get some solder onto my tip, and then use a small tool like this. Just hold it in position, really. Try and do this. Hopefully you can still see. That's it. I might need to just reflow that in a minute, and then just rotate it around. Do the same thing on the other side. A little bit of solder. Hold it down. There we go. That's not too bad. If you just add some more flux and then heat it, you should get a nice smooth edges instead of those sharp bits of solder you can see there. We'll just try that now. Let's get some flux on the edge there. Probably better off cleaning it up after we've done all the work, actually, after we've got all the components on there. But yeah, there we go. Got a bit of solder on that pad there, but we're going to be soldering a wire onto that anyway, so it's not a big deal. So hopefully you can see that. There, it's quite tidy, other than that little bit of solder on that pad, but like I say, we will be soldering a wire onto here, so that's one down. I'll just repeat the process for all the others now, and then I'll show you the assembled result. So you can see the board almost assembled there now, so yeah, components aren't that straight, and we've got some large blobs of solder and stuff on the edges of some of these. So what I'm going to do is clean this up, clean off all the flux with some IPA, and then heat it with hot air, because all the components should then centralise, if you like. The heat will actually, on both sides at the same time, will allow them to flow and move into position. I think under the temperature there, the tension, surface tension of the solder should pull them into the right alignment. So yeah, we've got a couple of caps to go on here yet that I'm waiting for. I think a couple of small electrolytics, and the 3 electrolytics for here, so it really is just capacitors I'm waiting for. So you've seen on the previous video that I fitted the socket here. I think what I'm going to do is I'm going to swap this socket for this socket. If I just disconnect the bloody thing here, you'll see it's 8 or 9, 1, 2, 3, 4, 5, 6, 7, 8. It's an 8 pinned in. But the beauty of this is if I wire this correctly, if you remember, the reason I used this 5-pin one because it used the same standard 5-pin DIN. In fact, I bought a cable for the TurboGrafx 16, I think it is. So it's the standard cable there that I'm using for the composite. So if I wire this one the same, it's got the same profile there of those 5. So my composite cable will just work with this socket. Or I can use this connector with a SCART cable to give me RGB using the remaining pins for the red, green and blue. So I think I can get both is the point I'm trying to make out of this. Leaving the standard composite, pin out there for a TurboGrafx 16, which would work with the TurboGrafx 16 cable I've got, but I could also alternatively plug in an RGB cable. So I think that's what I'm going to do. So you can see the audio amplifier here from the previous mod. I'm just going to unscrew this now, I think, make a note of which coloured wires are going to which pins, and then get the other socket on there instead. Just wire up composite, test it to make sure composite's working, then wire this in. I'll use another one of these over here to hold the video, the RGB amp in this corner over here, and then reassemble it, and all being well, it should work. So just testing loosely here, you can see got the new connector on there. Yeah, it's just hanging out the back, just loosely connected. Pointing at the screen, see I've got the composite and stereo working with the normal, the normal cable I was using before, but I've got the 8 or 9 pin, I forget how many, I think 8 pin DIN socket on there. So that's really good because it gives, like I say, a good level of compatibility with an original TG16 composite cable. So, not easy to work on this, I have to admit, it's pretty tight. So the next step for this, I might pull that damn thing off actually and glue the damn thing in and just put a couple of wires on it, because it just annoys me that much, that LED. Yeah, so the next thing to do here now is to wire in this RGB board, connect my red, green, blue up and feed the outputs. Well, this needs power as well. I think what I'll probably do is mount it here first, because it's going to make it easier. Join up my red and my black here, so my +5 and ground from the audio amp across here, so I've got some short wires. Forget which pins they are now, I think they're on this side. We've got a ground down here, got VCC there, so I can power that from some connections across here to save me room, more power wires across from there. It'll be held in place, and then I can just simply join up red, green and blue. I've got some wires here, they're probably a bit long, so I'll need to cut these down so they're just long enough to go from the underside of here to the inputs, and then obviously stick some, probably use the remainder of these chopped off. I might need another wire actually, I don't want them to be too short, and go from here to the three remaining pins I've not used here. Now, because I've gone with the standard TG16 pin outs, I'm trying to think where the gaps are. We've got a gap here, one here, one here, and one here. So we've got 4 pins actually to choose from. So I'll go red, green, blue. I might even put the red, green, blue on the outside pins, and then put the standard separate sync into the centre pin there, because whilst the composite might be okay to drive that, I think I'd rather pull a 4th wire off and feed that out as well, so I'm just using the sync rather than the composite sync. I might get a clearer picture that way, if that's the way if I route it that particular way. So I'll get one of these little clips now, clip this down, and then just do all the things I've just discussed. So I've got the red, green and blue connected to these first 3 pins here next to the yellow. That yellow is the composite video out from when I did the first mod there. So it's, it's just like those first 3 pins, red, green, blue. Okay, well there's not enough connections on this 8-pin DIN here to have the switching signal and the composite, actually on the sync. I've already got composite, so I'm going to go with composite and see if composite will drive the RGB if you use that as a sync. But you can see you've got the RGB in down here, +5 coming from this board here, the ground coming from the amplifier board as well, so 2 short power wires there, and then my red, green, blue and switching. Switching is going to the centre pin. So I've just drawn a diagram here so I know from the inside which colours are which, so I can wire up the RGB cable. But before I do that, I just want to get this thing back together. I'm not going to screw the socket in yet. I'll need to drill some pilot holes and get some screws and nuts and things for that, so I might have to do that later. But yeah, I'll just reassemble this now and test it in the composite mode just to make sure it's still working. So here's the results. You can see there's like I don't know, probably one of the colours or something. I suspect actually it's the switching line is not strong enough. It's kind of like bright. You see, look, the colour stabilised there for a minute. Let's just see what the game looks like. Yeah, colours are all over the place. So I think what I might do is just reduce the size of the resistor I've got between pins 8 and 16. Yeah, other than that, that's actually not bad. Yeah, I'll swap that resistor and see what difference that makes. So, sorry about the rain. Here's a quick update. Got the RGB cable connected now. Switch it off and on. Just watch what happens. Watch the colours I'm just looking at the viewfinder. Now it looks a little bit washed out there. Now just watch the green. See it go brighter? Now I think my first thought was maybe you just need some resistors on the output, maybe 75 ohm or something like that. But I tried that, it didn't seem to make a difference. So either it needs resistors on the inputs, again perhaps of 75 ohms or 33 ohms, something around that. But yeah, I mean if I start the game, you'll see the other thing here is it's something to do with the brightness levels, and they seem to be affecting each other. See the text at the bottom, it looks blue. Now just watch as it fades. Watch, blue. Watch this. White, it goes white as it fades out. So it's almost like if one colour is particularly strong, it's altering all of the colours as a result. I'm wondering if the levels are just too high. So when you get like a really intense blue, for example, it's then the TV's adjusting and shifting the other colours down to compensate for that ridiculously high blue level. Maybe the amplification's too high there, or so it's too strong. But in general, it looks okay. Can you see down, if I just move the camera down a bit, can you see down the bottom here now? The ghosting's all gone. The way I solved that was making sure the cable was properly shielded. So I think this was a fully wired SCART cable. It had all the connections wired, you know, so there's like 20 separate cores in there. And all the unused ones previously were just floating, whereas now they're connected to the common shield, you know, the shield that's wrapped around it, and they're all going to ground, all those unused pins. So that made a huge difference to the picture, but I'm still left with a scenario where it just seems a bit too bright. I would say it's like 20 or 30% too bright. And as I say, adding resistors on the RGB lines on the output isn't fixing it. So I'm going to go back and check the schematics, because I've got the suspicion that the resistor sizes on the input are not right. On the board it says 3,1 resistors, you know, and I think I've misread that as 3 1 meg resistors, and really it meant 3.1 meg. Instead of putting 3M1, they've put 3,1. So I think maybe that's what the problem is. So I'm going to try that next. I've got the nearest I can get with some 3.3k resistors, 3.3 meg resistors. So I'll get a 3.3 meg resistor on each of those lines there. I think it's actually a pull up. That's where they're going. It goes between 5 volt line and the RGB lines, you know, via this 3.3 meg resistors. So we'll try that and we'll just see if that solves it. So there you go, final result. I've just swapped out the 3 1 meg resistors I had there for standard type, you know, quarter watt resistors there. Just because it's all I could find, I couldn't find any 3.1 meg. Now I've used 3.3 meg resistors there, and I've just tested it and it looks perfect. I'll show you in a minute. So the other thing I'll just show you here is the connector. You know, the way I did that is I heated, I've got this pointer thing here, I heated this using hot air, and then it marked my positions where my screws needed to go in and just pushed it into the plastic to almost like pilot a hole there, and then use little self-tapping screws here to screw right into the plastic, and that's made a really good fitting. But the nice thing with this is it's compatible with the TG16 composite lead that I have, you know, an official composite lead, no modifications required. You can just plug it in and it works, or you can use the RGB lead and that works as well. So here we go. As you can see, if you look at the green there, it doesn't change in contrast or brightness. Well, it does ever so slightly, it's not really noticeable. That's what you would expect, really. That looks really good. Colours are really vibrant there, really clear. Let's start the game. Let's see if that text is in white. There you go. Can you see the white text at the bottom now, sort of blue? Wow, that's brilliant. Sorry about the rain, it's really pissing me off at the moment. That's really clear. Can't get over how good that is. And I've not noticed any banding. If you look at the, well, there's a little bit. Can you just see here? There's just a little bit on the blue there, you know, gel bars, but it's very, very light. Now, there are a few things you can do about that. I've seen people do mods where you stick a small capacitor across a couple of the pins on the 2670, I think. It might be the 2660, yeah, but the DAC 2660. Sorry, 6260. So I might cover that in a later video, but actually I'm pretty pleased with the result there. So yeah, just for now I'm not going to do anything with that, just going to have a play around with it, test it. I've got the turbo overdrive here, so I'll have a quick play with that and try a few different games out on it. Yeah, there's definitely some blurring on the edge of that D there. It's nowhere near as clear as it is on RGB. So you can see there, Composite, that's well blurry compared to RGB. I'm amazed at the difference actually. I wouldn't want to go back to Composite after this. Look at that. But it's useful for captures, you know. Interesting thing on this game is the controls are reminiscent of the arcade. You use the two, you know, you use the A and B buttons for going left and right here, and you can see that. But yeah, that's definitely very blurry. Just for comparison, this is Operation Wolf on Composite. Yeah, it's not too bad, that title screen, but yeah, it's a little bit blurry. It's not as sharp as the RGB. Start the game here. You can see you get blurriness here on the blues and things, you know, these little, the banding just down the blues. It's certainly not as sharp. And you get some weird, you know, colours flickering and stuff like that you just don't get in RGB. Can you see there? That's, yeah, really blurry. And it gives a nice effect actually on an LCD like this with the Composite. You know, it gives you a natural sort of blurriness effect, if that's what your thing is, you know, if you like that. But actually I think I prefer it in RGB. Can you see here, if I just move my finger, can you see this grey fence in here? There's like a shimmering thing going over it. I'll just see if I can cut to an RGB shot so you can see that that's not present. There's just so much more definition there. You can see the pixels and the, you know, the scrolling as the screen scrolls, and they're not blurring like they were before. It's much sharper. I mean, if you've got a critical eye, you can perhaps just see it. If you look at the blue sky right at the top here, there's just a tiny little bit of band in there, you know, gel bars, just ever so slightly, but it's very negligible. The main thing is, you know, it's the difference between this grey fence here. You can see it's just crystal clear. If I just zoom in a little bit so you can see, you see it's just not blurring at all. Some interesting lines coming out of this capture here. I'm not sure whether it's going to get captured. Oh yeah, those lines, it's just the LCDs. You know, they're not, you don't see them to the eye, it's just the way they've been captured on this camera. So looking back at this board again, the revision I did earlier to this was, I think the three of the resistors here that I thought were supposed to be 1 meg. I'll show you this, I'm not sure how it's going to come out. Yeah, R1 to R3 there, 3,1 mega ohms. That really should say 3M1. It would be a bit more obvious. I thought that meant 3 1 mega ohm resistors. That's why we were getting the you know, the fading in thing with the colours there. It needed at least 3 meg. Now, when I looked at the what's it called, the data sheet for this THS7314, one of the things it suggested was using 3.6 meg, I think, or 3.5 meg. pull-ups on the 3 inputs. So it's interesting that this has been, you know, laid out here to suggest you need 3.1 megs. I've used 3.3s and got a pretty perfect crystal clear picture. So yeah, I would surmise from that sort of around the 3.3, 3.5, 3.6, somewhere around that region, whatever size resistor you can get there, it should be okay. I think anything between 3 meg and 3.6 meg is going to give you a pretty good picture, but nearer to 3.5 is perhaps where you want to aim for. And if you're interested, that's the wiring diagram I went for. Now this was my notes here taken from the inside of the back of the socket. So as you look at the solder points on the back of the socket itself, this is how it was wired. You know, I had my black at the top, that top pin there was the ground, and then I had one of the audio channels, I'm not sure whether it is right or left, and then the other one down here, my red, green, blue, composite, yellow, and the centre pin I've used for the RGB switching signal. Now there's a couple of ways you can improve this, and I might do this actually. This PCB here, coming back to this again, down here you can see there's a position, where's it gone now? There for resistor, and it's 100 ohms. And the way this works, I think it goes to this bottom pad here, which is marked BLNK, which I think is the blanking signal, the RGB switching signal. And all it's doing is it's feeding 5 volt through that resistor, through a 100 ohm resistor to that pad, and that's what I've got going to the centre pin there. So that's switching my TV into RGB mode. But at the moment my SCART cable's not wired to use the switching signal, not the RGB switching, but the other one, the actual channel switch. Is it pin 8? I think it is, I think it's pin 8. So what I could do is remove the 100 ohm resistor, and I suggest you do the same if you're going to use this board. Remove the 100 ohm resistor, just solder a link across so that your 5 volts is coming straight through to this pad here. Join that to your switching position here, so you've got 5 volts there effectively. And then on the SCART end of the connector, run that wire, this wire here, to pin 8, and then you use a 100 ohm resistor between pin 8 and pin 16 to put your TV in RGB. So then you've got both working. I'll switch your TV onto the right channel, and I'll also switch into RGB. Anyway, I thought you'd find that interesting. Thanks for watching. I'll see you soon.